Virtual Machine Sequence, Part 4. We are narrowing down to the end of this manual, and the next phase is converting the latch rungs to seal-in rungs, and then go through and clean it up and get it working properly and getting more than one part to run through it. To that end, we're going to start by replacing or editing the rungs to eliminate the latches and unlatches and just go with seal-in logic. And to do this, we're going to go offline because it'll make the editing much quicker. We're going to start with rung 2. Remember, rungs 0 and 1. These two rungs are what I call a poor man's HMI. You don't have a man-machine interface in front of you to watch what's going on. You can't be everywhere in the logic at once. So you just bring up the bits that represents the steps and watch them step through. Now, when I went offline with this, you can see this is right where we left it. When we had a couple bits turned on, I can just toggle those off from here because remember, we're offline. And when we save and download this anyway, it's not going to make any difference. So let's move down to this rung and show the replacement rungs. The replacement of the first rung is probably more complex than what you were expecting, but don't be surprised because remember I told you that doing seal-in logic is more complex than doing latch and unlatch. Latch and unlatch is the easiest way to program, but it's also the most confining, and everything becomes interdependent and tangled, and it's difficult to do any nice clean sweeps through to change the functions. So here we have this rung that if it saw a new part, start a timer, that timer timing pulse of 1 second went over to another routine, barcode scanners, and sent back a value for N7:0. And it also, of course, turned on B320/0, the trigger, over to that other program file, and then latched this bit to say that that step was complete. And of course, we don't have any step completes now, we just have logic. So if we drop down here, you'll see it's a little more complex. If we get a new part and the barcode trigger pulse is not done, so T410 not done, that's this guy right here. And obviously, if it's not done, then we can execute it. There's also a new part expire timer, which is down here, that says if the part number N70 is greater than 5,000, it's going to turn on B320/6, and that's going to start and it's also going to enable T414, which is a 10-second timer. And when that is done, when this timer is timed out, 10 seconds later, it's going to clear N70. This will go false and the whole run goes off. But in the meantime, when the part is greater than 5,000, which came back from the barcode trigger, turned on B320/6. This is true. Cylinder 1 and 2, and we only care about cylinder 2, but it's not extended yet, and the new part has not expired, then it seals in this part number right here until this all expires. And when it does expire, it is going to clear N70 and it's going to turn off the new part Q. So you got 10 seconds for things to happen. And the reason we don't just leave it on indefinitely is because we have to make some practical assumptions that once PE sees a part, the barcode scanner scans it, sees it's greater, the part number is greater than 5,000. Within 3 or 4 seconds, it should have moved on. So we just give it a 10-second timeout. Now, some of this was added after the fact because we realized certain nuances that may not occur to you up front. So that's probably one of the more complex results of replacing this simple bit here with seal-in logic. But you see there's no latches there. So this logic operates totally independent of everything else in the logic. And of course we've got B330/1 extended procs for cylinder 2. That's from the cylinders routine, so it's connected to that. So it's not 100% independent. It does require that it's see a new part and that the cylinder move, etc. So we will take and delete this rung and then finalize these two. Okay, that replaced the first rung. And now this rung we don't even need. We never latched a bit. In other words, we eliminated that up here. We're not latching any station 1 bits. So that eliminates this rung. The next rung, now we replace this rung. When the previous logic was complete, we cleared N70, and when the photo eye saw the part arriving at the entrance to the station 1, and there was not a part already at cylinder 2, I say I misspelt that, that should be CYL, not a part at the end of cylinder 2 end of stroke, then we extended cylinders 1 and 2. When they were extended, then we said there's a part at cylinder 2 end of stroke, and then we latched and unlatched, which none of this, we still have this B320/5, but we're no longer doing B310 bits. So if we drop down here and look, we're saying we have a new part Q. If photo eye 2 sees that part, then we clear N70. Now we might have been able to squeeze these 3 rungs into 1 rung, but it makes for much more convoluted reading for the maintenance person, so we do it in small pieces. So this clears N70, which we did up here. Then this is the same bit, B326 right here, and this is the same photo eye. So you see what I'm saying? We could have combined some of this, but it's easier to read this way. Got a new part in the queue, the photo eye sees it, and there's not a part already at cylinder 2 end of stroke. OTE, true execution, turns on output 0. Goes out and energizes the solenoid and extends cylinder 1 and cylinder 2. Then this bit seals in this logic along with a bit that you may not have thought of yet, but we have to have some way to drop this rung when we want cylinder 1 and 2 to retract, correct? So when do we want cylinder 1 and cylinder 2 to retract? When do we want to release, or rather do the false execution of the OTE? And so we turn off output 0, and as a result, cylinder 1 and cylinder 2 retract. Well, if you just think of the process, the last thing that was completed before we retracted cylinder 1 and 2 would have been when we finished drilling the hole. So at this point, I just made up a bit called boring completed. You might want to say, well, the boring's completed and cylinder 4 is retracted, because remember, that's what pushes the bit, the rotating drill bit into the part. So it will be up to you later on to make sure that the logic that you write to turn on B320/7 includes the fact that cylinder 4 is retracted. When that happens later on, then the new part Q has cleared out, PE2 no longer sees the part, and now there is a part at cylinder 2 end of stroke, so that's all going to be false. But the bottom part, sealed in, would keep cylinder 1 and 2 extended if it weren't for the boring completed bit. And then, of course, we have the logic that turns on the bit that says there's a part at cylinder 2. Even though we use it here, logically it doesn't occur until later in the sequence the first time through. So it doesn't matter what order you put these rungs in. I put them in an order that makes sense to me and how I see the process. So this third rung says cylinder 1 and cylinder 2 have extended, therefore there is a part at cylinder 2 end of stroke. That bit then keeps this sealed in until some point. When do we want to turn off the bit that says there's a part sitting there in the workspace? Well, the obvious is when cylinder 3 extended prox is not on. Now there's a bunch of ways you could do this. You could turn this bit off with anything downstream, but you want to do it with the first occurring incident or event that would work out well for you, because the faster you clear these things, the faster you can bring in a new part. So I chose not extended because it's not extended while it's retracted, right? The part would have been pushed out of the way and cleared the workspace, or clearing the workspace before I remove the part at cylinder 2 into stroke. In other words, cylinder 3 pushes it over on the finished product conveyor and then comes back. So you could have done a one-shot thing here to clear it out, which might be more effective. We'll leave it like I did it and then see if we want to improve it later. So I'm going to go up here and I'm going to delete this rung and then finalize these. This is our next rung to replace, the rung that turned on the drill motor and extended cylinder 4. Okay, here we are replacing the rung that turns on the drill motor, and then we delay extending cylinder 4. If you take out the latch and unlatches, these rungs look a little skinnier. So here's what we did. We're saying if cylinder 2 is extended, then turn on the drill motor. Okay, so we extended cylinder 2, extended prox is on, turn on the drill motor, and then after a 3-second delay, we're going to extend cylinder 4 to push the drill bit into the rotating drill bit into the part to bore a hole in it. But we have a condition because cylinder 2 is extended. The drill motor is on, the timer is done, and we extended cylinder 4. How do we turn off cylinder 4? We're not latching it. This rung would be continuously true unless we had something in here to interrupt cylinder 4 extended. This is a bit that I made up right here. I just said retracting cylinder 4, B30 size 0. It's an unused bit. I says we're not retracting it, therefore extend it, because later on we want to retract it. Okay, and that replaces this rung up here. So I'm going to delete this rung, finalize this rung, and go to the next one. And to make this simpler, I think what I'm going to do, even though it won't match what's in the book, I'm going to take and delete the latches and unlatches for B310. Whoops. Didn't want to do that. Meant to be down here. Delete, delete. Down here. Delete, delete. Okay, so now this was the one that we just did. Okay, so this is the one that's going to unlatch or would have turned off that bit. See, unlatched bit 2, but we got rid of the latch. We're not latching output 2 now, we're just turning it on. So we need something to cause it to release. Add that logic in. Here's our solution. When cylinder 4 prox is extended, we need to extend it before we can retract it. And remember, we wanted to delay retracting cylinder 4 to give the bit time to kind of screw auger out, if you like, the debris. So there's our 1 second delay. Delay retract cylinder 4. When it's done, then we turn on the bit B30, which was up further up here, that we used to turn off right here. See, B330, that would drop out the output. So back down here. So when the delay is done, then we turn on B30 and it seals itself in until cylinder 4 is not retracted. Okay, in other words, right now it's not retracted, it's extended, right? Remember? Extended. Cylinder 4 is extended. Starts the timer. When the delay is done, it turns on this bit that allows in a previous rung to turn off the output that's extending cylinder 4. So until cylinder 4 is retracted, this is false, and this seals itself in, and the instant that cylinder 4 returns to its retracted position, then this rung drops out. And we're good to go to the next section. Here's T412, T412, so we delete this rung and finalize these two rungs and go to the next one. We really don't turn off the drill motor in this fashion. So we're going to replace this rung. Okay, we're going to replace two rungs here because they replace just one rung wasn't enough. So we're basically replacing a rung that turned off the drill motor, in a way. And it's this simple. When cylinder 4 retracted procs sees the piston return, that means that it has bored a hole and the cylinder piston has returned to the retracted position. We one-shot that to turn on B327. Remember, we used boring completed up above to accomplish something. I told you at the time that it's up to you to make sure that the logic you put on in to turn on that bit does the job. Now we one-shotted it, which means this is only going to be true for one scan. So if this rung were to get moved prior to that other rung, it may or may not work. It could get shuffled around so it doesn't work later on, but we're going to leave it like this for right now because this only has to be on for one program scan. So it hits here, the first time it sees the procs retracted, cylinder 4, done boring, one-shots that bit. It stays on until it gets back to here, but in the meantime it has to go through all the logic to get back to here, and when it gets to the place where we use B320/7, which was, it's hard to find, scooching around through here, right here, boring completed. Remember that dropped out the cylinder 1 and 2 extend solenoid. If the boring is completed and cylinder 4 is retracted, then we could go ahead and retract cylinders 1 and 2. It no longer has to clamp the part into the V-block. Then also, once cylinder 1 and 2 are retracted, then we want to extend 3 to push the part out. And that's this rung right here. We said there's a part at cylinder 2 into stroke. We did that up in a previous rung, up higher. And if cylinder 2 is retracted, that's the only one we care about for cylinder 3. Cylinder 3 can't collide with cylinder 1. Even though 1 and 2 extend retract together, we don't care about 3. You could put it in here if it makes you nervous, but we only care about cylinder 2 retracted proc switch. So we got a part at cylinder 2 into stroke. That doesn't mean it's finished, but when we hit the boring completed, then it is finished, and that's what caused cylinder 2 to retract. And when it's retracted, we know the part is finished. If there's no part already on the finished product conveyor at cylinder 3 into stroke, then let's turn on cylinder 3 and extend it. And then seal that in until we're done delaying the retract of cylinder 3. That'll then drop out output 1 and cylinder 3 will retract. I can delete this rung and I can delete this rung. Finalize these two. Now we go down to the next one. And we have a couple more things here that we can delete, latch and unlatch, just to get them out of our face, right? The only problem with doing this is then it doesn't match the book. In the book, I didn't have you necessarily remove all that. This rung, cylinder 3 extended procs, says there's the part at cylinder 3 into stroke, starts a delay, and then it turns off cylinder 3 extend solenoid to let it retract. We replaced it with 3 rungs, and these replacements are not clean. They're not rung for rung replacements, but they're as close as we could get. We start out with cylinder 3 extended procs, just like we did in rung 12. In our new rung 1213, we start out with that same condition. Remember, we've eliminated the station 1 B310 bits. So we start out with cylinder 3 extended proc. So cylinder 3 has extended. We wait for a delay to retract cylinder 3, which we've already used. We use it up here in an earlier rung. See? Delay retract cylinder 3 not done. We needed that So we could seal in cylinder 3 extend solenoid, sealed itself in until this times out, this goes false, and then it retracts cylinder 3. This rung right here, in a sense, replaces the unlatch output 1 that extended cylinder 3. Also, if we turn off that solenoid, which was caused by this timer timing out, and then when cylinder 3 retracted procs and extended procs, neither one are true. Now picture this. Cylinder 3 was extended, right? And the timer right above, T413, when it was done, it interrupted the rung that was holding that output on. So at that point, cylinder 3 is retracting. If you turned off cylinder 3's solenoid, meaning it's retracting now, and neither procs is sensed, there's only one conclusion that you can draw, and that is that it's retracting. It's in the process of retracting right this instant. If you look at all of the events between two procs on a cylinder, let's start out with it's extended, okay? That's one case. Then when this goes false, that's a second one. Both of these false, that's another one. Retracted, made, and this one not, that's another. So if you look at the sequence of events, we'll start out, it's retracted. Then it's neither retracted nor extended. So the only way at that point you can know whether it was in the process of extending or retracting would depend on the state of the output that controls the direction of the cylinder. So the cylinder, the solenoid that controls the position is turned off, therefore we know it's retracting. Neither proc is on. So at this instant, it's retracting. We turn on this bit to say that there's a part at cylinder 3 end of stroke, and then we seal it in until another bit comes on that we created in our third rung here, and that is the cylinder 3 end of stroke is clear. There's no part there. Okay? That drops this out. It gets rid of this virtual sensor that acts like a photo eye to say there's a part at the end of stroke of cylinder 3. What turns that bit off is when the leading edge of PE3's optical path is broken, the leading edge of this input going on, true if on, one shots, and if the finished product conveyor is running, I mean, somebody could walk by and flick their fingers through this, and that would undo our part at cylinder 3 end of stroke. We don't want that to happen. Now, they could still do that while the finished product conveyor is running. So we're saying when the part moves into photo eye 3's optical path while the conveyor is running, then turn this bit on for one complete scan, and it will drop out this. It will drop out that condition. We can remove this, the latch unlatch stuff, and finalize our replacement rungs. Okay, that brings us down to this rung, which you could say that this one got rid of cylinder 3. So let's see what we did next. One thing I didn't mention is anytime you see an unlatch or a latch, some rungs we have to replace. Some we just eliminate. This one, this was what turned off the latch bit 20/5. But remember, we've already created the logic that turned on this bit, and within that rung is the method that clears this bit. So we can just select that and hit delete. We've already eliminated that function. Now the finished product conveyor, and I already deleted the latch and unlatch underneath of it just to give us more space. This one was a lot simpler. These have been eliminated, so we really have these three conditions. If cylinder 3 is retracted, then it's not in the way to interfere with the part moving on the finished product conveyor. And if the photo eye at stop 2, in other words, photo eye 3, if it's clear, there's no part there, and if cylinder 5 is retracted, then turn on the finished product conveyor. Well, here we've got, if cylinder 3 is retracted, same condition as up here, and we have a part at cylinder 3 end of stroke, and PE3 is not blocked, then start the finished product conveyor and leave it on until these conditions are no longer true. So it's an unconditional, there's nothing sealing it in unless there's a downstream call. Here's what's going to happen. You probably would have had just these 3 instructions and this instruction, not this one. But in thinking ahead, what's going to happen is if there's a downstream call, then you want to leave the finished product conveyor on as long as cylinder 3 is retracted. That simple. We can delete this one and finalize that one. And then move down to our next set of conditions. Okay, this was going to control cylinder 5 extend solenoid. And if you eliminate the latch and unlatch stuff, you're not left with much. However, I did put in a rung here that the reason for escapes me right at the moment. No surprise. PE3 turns on part at PE3. So really those are redundant, but that's the way I did it in the manual, so I'm going to leave it that way. Maybe later on I come up with some brilliant idea why I want part at PE3 and use B320/9 with some kind of a timer that holds this on even after this clears. Because remember that if it clears photo I3, it hasn't cleared stop 2 or cylinder 5 yet. So maybe I'm going to use it as a delay. I don't know. And then this one, of course, is real simple. If photo I3 sees a part and there's no downstream call, then extend the solenoid. And then when this disappears, I wanted this anded and ORed. So if you want to write it different, that's your business. But if PE3 and not downstream call, then turn on cylinder 5. And then seal it in, extended. So the only thing that's going to interrupt this is the downstream call. There's going to have to be downstream call. And in a sense that I see now that makes perfect sense, because if you got a part setting up against cylinder 5 stop and it's blocking PE3, it's right against stop 2 because cylinder 5 is extended. Nothing is going to change that until you have a downstream call. Otherwise, there's no place for that part to go. So I see now why I did that. So I'm going to delete this rung, finalize those 2, and looking at the rest of these, this unlatches the finished product conveyor, which we don't need, nor do we need to latch, unlatch any station bits. This one allows cylinder 5 to retract and latch station bits. We don't need that. This one turns on product conveyor if there is a downstream call. So if we go back up here, see if there's a downstream call, then it's going to turn it on. So we don't need this one. We don't need to turn off, and we don't need this to clear. Now I'm going to leave this in temporarily. Before we did our testing, I said, what is the significance of our existing reset rung? Do we need to clear station 1 integer? Well, no, but I'm going to leave it in there. Do we have bits to clear like part at cylinder 3 extend or part at cylinder 2 extend? No, we don't. So we don't need to clear station 1 integer or clear those parts. Do we even need a reset rung with our style of logic? Probably not. But I'm going to leave it in there until we're done, just in case I want to clear those bits. How close is your logic to what's shown next? I did not include the JSR rungs. So I have a couple pages for you to go through and compare your logic. And so I'm going to pause and be back. I noticed here that in the manual, I decided that there's no downstream call then cylinder 5 can be extended. That's simple. So I'm going to eliminate. In other words, Boolean algebra would have eliminated down to this. No downstream call, cylinder 5 is extended. And that really tidies it up. So I went through, and as far as I can see, my logic matches what I have in the manual. Remember that when I originally did this, I did this code as I was writing the manual, not after the fact. In this case, it's after the fact. And so I may have a typo in there. If I do, we will find out soon enough. I also had you check your virtual cylinder logic and your barcode reader. And then I had you edit your poor man's HMI, MMI, man-machine interface. So I expanded this to 3 rungs to allow some more indications in there. Here we go. We no longer have all of those station numbers, and really we could see them sequencing, so we knew they were going in order, but there were no descriptions. I see I have one there that I did not delete. We see, and this is kind of in the order of the way things go. Barcode trigger, new part Q, cylinder 1 and 2 extend. There's a part at cylinder 2 end of stroke. We turn on the drill motor. We tell cylinder 4 to extend. We retract cylinder 4. Boring is completed. We extend cylinder 3. There's a part at cylinder 3 end of stroke. Cylinder 3 end of stroke is clear. The finished product conveyor is on. A part at PE3, we've extended cylinder 5, extended solenoid. That's much more usable than what we had before because they were steps in order, but the descriptions just didn't get it. And before we tested this, I added in the logic that I told you from the beginning was very important for machine safety, for the health of the machine. So you can't extend cylinders that are going to cause the fixturing to collide or have interference.